These are two inequations. X square minus 5x plus 6 greater than 0 and x minus 1 into x plus 2 the whole square into x plus 4 is less than 0. We need to find the range of x that satisfies both of these equations. So I'll just say and. So I need the x range that satisfies both these inequations. So there is a trick to do this. I'll explain the trick. There is of course a brute way to do that, uh, which is which is given in some textbooks, but there is a trick to do this as well. The second inequation is already factorized, so we don't have to worry about that. So we'll try to factorize the first inequation. So this is actually x square minus 2x minus 3x plus 6 greater than 0. So why did we split the middle term minus 5 as minus 2 and minus 3x? That's because this one, the product, this signifies the product is 6. So what are the factors of 6? It's 1, 2, 3, and 6. 1 into 2, 1 into 6. So 1 into 6. Because the product is positive, both of them have to be negative so that the sum is negative. Because negative into negative will be positive. So minus 1 minus 6 is minus 7, which is not feasible. So the other factors are 2 times 3, and minus 2 into minus 3 is plus 6, well and good, and minus 2 minus 3 is minus 5. So we select this. So that is something which you would have learned in either 8th standard or 8th grade or 9th grade. So I won't go into that in more detail, but this is the way you factorize. So I'll now say x into x minus 2 minus 3 into x minus 2 greater than 0. So which actually means x minus 3 into x minus 2 is greater than 0. Now, this is the inequation, and there is a simple trick to find out the range of x that satisfies this. I'll put this in blue. This is the number line, and this is 0, 0, 1, 2, 3, 4. So I'll just say 1, 2, 3, and 4. Now I will select a pen, and this is the trick that I was talking about. We come always from the upper side, from the positive side, I would say, the positive y-axis, if you can imagine. So x minus 3 and into x minus 2 is greater than 0. So our target is how to make this 0. So this becomes 0 when x is equal to 3. So this and this, these are our targets. So 2 and 3. So what do we do that? So when we come from the right side up, we first meet 3, then we go down, and then this is the other factor. Is there any other factor? No. So we just go directly there. So this is the positive side, and this is the negative side. And Because this is greater than 0, we need to focus on the positive aspects, which is we are focusing on the number line which is on the right side of 3 and on the left side of 2. So this is the simple equation. This is a simple solution for this, the first equation. So x has to be greater than 3 or x has to be less than 2. So only in these cases, the first inequation is greater than 0. So is it clear? Because there are two roots, I would say, 2 and 3. So we always approach it from the positive upside. So we go from positive and then go down and meet the first root, which is 3, and go down, come up for the second root, and then go up. And since this is greater than 0, we want to select the solution only from the region which is above the x-axis. So it's greater than 3 or it's less than 2. This is the solution for the first one. Now the second one is even more straightforward because it has already been factorized in the question itself. So what are the roots? So it's 1, -2, and -4. So what do we put x so that this becomes 0? So x 1, -2, and -4. So let's say it's 1, 0, -1, -2, -3, -4, -5 is 2. So write the numbers 2, 1, 0, -1, -2, -3, -4, and -5. These are the relevant numbers for us. So always we come from the positive upside of the x-axis. So what is the first root we encounter? So our interests are these ones. So it's 1, this is our interest, -2, and -4. These are our interests. So we come from the top, meet the first root, go down, and the second root is -2, but be careful. Here the -2 comes 2 times because x plus 2 square. So instead of going up, we'll actually bounce back and go to the next root, which is -4, and go up. And this is less than 0. So the range of interest is this as well as this, and not the positive ones, because the ones which are above are relevant if it is greater than 0, and ones which are below is relevant if it is less than. So I'll recap a bit. If it is, the root is 1, it starts from 1. So I come from the positive up side of the x-axis, go down, meet 1, and go down and find the next root, which is -2, because if I put -2 here, this becomes 0. So -2, ideally, if there was no square here, I would have just gone up and come back for -4. But then there is a square. It has to be counted twice. So this will just bounce back. If it were cube, then again it would have gone up. Because it is square, it bounces back and goes up for the next root, which is -4, because if we put -4, it becomes 0, and then goes up. And since it is less than 0, the range of interest is this, as I marked. So the range is, I'll say this here, -4 less than x less than minus 2, or minus 2 less than x less than 1. And here the minus 2 is not included. So minus 4 less than x So the common thing between these two is minus 4 to 1, excluding 2, because this range comes somewhere here. This entire range, minus 1 to 4, comes here. So somewhere it is minus 4. I'll mark this in green. Minus 4 to 1. So minus 4 to 1, this entire range comes here, which is already there in the first range of x. But then we should exclude 2. So the actual answer is, I'll put it in green, minus 4 less than x less than 1, and x not equal to 2. Because if you notice, in the second solution, the 2 was not included, excluding minus 2, I'm sorry. The minus 2 was not included. So x not equal to minus 2. So this one here, this was not included, neither here nor there. So minus 2 has to be excluded. So here somewhere, it comes somewhere here, the minus 2. It comes somewhere close to minus 4. So minus 2 is not included. So the solution is minus 4 to 1. So x ranges from minus 4 to 1, excluding minus 4 and excluding 1, where x is not equal to minus 2. That's the solution, because we have to search the range which is common to both of them. Thank you. That's the answer.